Hello, and welcome to this week's Ethical Dilemma in Science. We're going to take a look at mining for the 21st century, digging up precious resources and or bringing pollutants to the surface. Okay, so the idea for this week's Ethical Dilemma in Science came from an August ProPublica article talking about basically a town that is located in close proximity to a uranium mill, basically a location where they would take raw ore and process it and refine it and extract the uranium from the raw ore. Now, this is an operation that opened up in 1958 and eventually closed in 1990. But what has been seen is that the town that was located very close to that, and in some cases showing here on the diagram from the article, it illustrates that basically you've got the refinery operation kind of up here, and less than a half a mile away, they've got houses where people are living. Within a half a mile, 22.2 million tons of uranium waste. And so what they've been able to show over the last 60 years or so is this kind of increased contamination in the area. The groundwater in this area had radium 31 times the natural occurring levels and other kind of risks associated with it. Now, in this situation, the government regulators do not appear to have held the company accountable for the cleanup targets. They were producing uranium at a time where uranium was very important for kind of operations for both the military industry and nuclear power. So they were granted exemptions from the standard clean water, groundwater cleanup standards. Right now, the owner of the mill is attempting to buy out the residents and demolish the community. But the potential problem for this uranium waste kind of extends a lot further than this community. There's a number of indigenous people living in this area. The article also talks about there's at least 500 abandoned uranium mines across the Navajo Nation in that area. And so what we're seeing is that there are problems with this uranium that's been brought to the surface, both with the raw ore and the contaminants from refining that ore. Now, this isn't a problem just solely within the United States. A November 2022 article in Live Science talks about a South African diamond mine dam collapse. And so in this diagram, images from NASA satellites showing before the mine collapsing over here on the left-hand side, over here on the right-hand side, just a short time later. And you can see this kind of slurry that has been released by this dam and has flowed down through the river system, resulted in pretty significant flooding, wiped out houses and communities in that area, as well as leaving these trace quantities of metals such as copper, mercury, cadmium, and zinc, as well as other kind of byproducts of the mining process, including petroleum, sulfuric acid, and cyanide. And so, it's contaminated this downstream region of those mines. And, at this point, at least, it probably is going to be difficult to clean this up. Ultimately, this stuff is going to dry up and either be blown away in the wind or washed away further downstream in the rain. But again, those pollutants they're going someplace. And again, it's not just a problem in the United States, it's not just a problem around the world, it's a problem historically. This is an article from mining.com from October 2022 talking about a biblical copper mine in southern Israel. It's been estimated that this is the world's first copper mine, and it operated a little over 3,000 years ago, from about 11th to the 9th century BCE, before Common Era. And so basically what they do is, again, they take the raw ore that has been dug out of these mines, they would place it into these little earthen furnaces and heat it up. So they basically put charcoal, basically slow combustion of trees or bushes, form the charcoal, and then it can burn that and get incredibly hot. So they basically kind of bake these kind of rocks, bake these ores for about 8 hours at 1200 degrees Celsius. And in doing so, basically, it will melt the copper. The copper will be kind of flowed down and then separated from the other portions of the ore. Now, this was a mine that was in operation for about 250 years. The archaeological analysis has shown that early on they had high quality firewood using things like acacia trees and white broom trees. But later times they were using kind of less optimal sources of fire, less optimal things to burn, and they were potentially transporting in woody products to be burned. So in the absence of this high-quality fuel, this copper mine kind of stopped operation. It wasn't economically feasible to import the wood to kind of burn the ore and separate the copper from the waste materials. Now, 3,000 years ago was when this was in operation, but the local environment still has not fully recovered. Very sparse vegetation within that area because most of the plants were eliminated in order to be used as a fuel source for this. So they lost key species. With those species, they lost the ability to kind of trap water within the soil, stabilize the soil, and it basically has not recovered in over 3,000 years. So we end up with this situation of the need to mine for resources in the 21st century. And in many ways, the process of mining has not changed significantly over the last 3,000 years. You basically dig a hole in the ground, you find the raw ore, and you kind of take that ore out and process it in some way to get to the resources, get the materials that you're interested in. Basically, there are lots of resources that we need. The 21st century, we've all got, let's see where my iPhone is, got an iPhone here that I use, probably more than I should, but it requires 75 different elements. And those aren't elements that are easily found on the surface of the ground. They're not elements that can be, basically, plucked from a tree or harvested in some way. They require kind of a significant effort to be able to get to those resources and then obtain them. And so in this technological society where we are dependent on our cell phones and our computer systems and these modern devices, we have to have the resources, these elements, in order to build them. So as I said, the normal process of mining hasn't changed a whole lot in 3,000 years. So the goal is that you dig up the rock that is going to be containing the materials that you're interested in. That mined rock is going to be pulverized at some point, basically ground up or broken down into smaller particles, and then treated with something, treated with heat or potentially treated with chemicals in order to extract the minerals, extract the resources that you want. So in this refinement period, refinement process, we're basically taking this ground up kind of ore, this ground up rock, processing it and generating a whole lot of waste. And that waste is referred to as the tailings of a mine. So those are the waste rocks, those are the waste kind of contaminated, and they describe it as a slurry, what's left over after you've pulled out the resources that you need from that situation. And so you accumulate those tailings in some location. And so in the case of the South African mine, they basically had these tailings in a reservoir like this. The mine collapsed, and all of those tailings, all of that fluid, the wet rock and sludge, in essence, flowed downstream. With the uranium mine, again, they collected these tailings with the pulverized uranium rocks, which had other types of radioactivity associated with it. It was accumulating in a reservoir like this, and in that case, it was basically seeping into that ground and taking the radioactivity with it, contaminating the groundwater. So as we are increasingly dependent on these resources that are obtained by mining, there is this need to be ecologically and socially conscious of the impact of the mining. And so I think this is 2017, the International Association for Promoting Geoethics came out with a white paper promoting responsible mining, emphasizing both the benefits and the burdens associated with modern mining processes. Now, in most cases, mining is going to be occurring in kind of remote, generally less developed areas, so they have the opportunity to provide wealth and resources for that economy in that region. They can go in, they can build an infrastructure, they can provide jobs, both skilled and unskilled labor, and then funnel a lot of money into that community. And so there are benefits, but then again, there are risks associated with that. We see that in the contamination associated with the extraction of the needed minerals from the raw ore. Disruption of the ecology in that area if you're going through and either digging up large regions or kind of depositing those tailings, depositing those wastes in an area, and those wastes then could potentially be contaminated or kind of spread throughout that region. And so this white paper on responsible mining talks about what I'd like to describe as kind of a holistic, full circle approach to mining. So even before the mining starts, you kind of identify the region and then begin to engage the stakeholders. So go in and talk to the people living in that region about the impact that the mining is going to have. Learn about what they are going to be concerned about. Learn what their desires are. Try to identify the values of the mining company and the surrounding community in order to establish an alignment so that they are going to be protecting the environmental impact of the mining operation, minimizing the impact on the surrounding community, and ultimately still within this kind of holistic full circle approach, thinking about what's going to happen at the end of this mining operation. How are they going to be closing the plant down and potentially rehabilitating both the ecological impact and the social impact they had within that environment. Now, when we take a look at this, not all mining operations are going to be conducted with this goal of kind of ethical, kind of social consciousness associated with that. And so what we've seen are the rise of a number of Superfund sites since it was first established in 1980. And so this is coming out of the 1970s, where there were massive contaminated pollutants getting into areas like Love Canal, and the need to clean those up because they were poisoning people in those surrounding areas. So the Superfund actually comes from the Comprehensive Environmental Response Compensation and Liability Act of 1980, and this is the federal government's effort to address sites containing hazardous substances. Now, the goal of the Superfund within the Environmental Protection Agency is to force the parties that are responsible for the contamination to perform the cleanup, or if they're not going to perform the cleanup, hit them with fines so that they are reimbursing the government for the EPA-led cleanup operation. Oftentimes, though, what we're seeing is that the companies that are producing these pollutants, producing these hazardous substances, often go out of business, go bankrupt, and so there's no viable, responsible party, resulting in the Superfund having to use government funds in order to clean up these contaminated sites. And so, the goals of these Superfunds are to protect human health and the environment by cleaning up these contaminated sites, ultimately to try to get the people that contaminated it, the responsible parties, to pay for it, but ultimately to involve the communities in this process, again, that holistic view, so that they can return these Superfund sites to a productive use. Now, a major concern with this, and a major concern with these mining operations, is that many of them are in areas that are susceptible to the impact of wildfires and flooding, which, as we've seen over the last few years, are going to be exacerbated by the climate change. Massive wildfires associated with the droughts to the American West, lots of flooding that we're seeing in other areas, because when it rains excessively, resulting in flood. Potential rising of the sea level could impact a lot of these sites along the East Coast as well. Now, the risk of this, the wildfires and the flooding, is that they could spread that contamination beyond the site. Kind of getting it up in the air in the sense of the wildfires, or potentially washing it downstream or contaminating other water sources if we're taking a look at the impact of flooding. So that gives rise to our ethical dilemma in science for this week. How do we minimize the social and ecological impact of mining? Should geoethics be mandated in the planning? So basically from the beginning, in the planning, the ongoing operation, and ultimately the cleanup of the mining operations to return that land back to a productive use. How do you ensure that the necessary funds and resources are available for mitigation of the mining impact? Basically, if we're getting to the point where the mine is in the process of closing, it is no longer generating revenue. So it's not generating the resources that may be required in order for them to return the land into an ecologically sustainable, productive use of some type. So thank you for listening to this week's Ethical Dilemma in Science. Please see the description below for additional information and references. Thank you, and have a great week.